Hey everybody, this is Unit 3, Formative 3, Solving by Elimination. This will be day 1 of Solving by Elimination. Okay, so when we talk about elimination, we are talking about basically getting rid of a variable. So we want to, in other words, eliminate a variable. So it's exactly what you think elimination would mean. Okay, so here's just some quick examples of what we would do with elimination. So we want to figure out what would we add to 2x to make it equal 0. Well, we would add negative 2x to it to make it equal 0. So that's what we would use to eliminate the positive 2x. Okay, well, what would we add to negative 3y to make it equal 0? Well, we would add a positive 3y to make those cancel out. Okay, and then what would he add to x to make it equal 0? Well, we would add negative x to make it equal 0. Okay, so that means that these would eliminate, the y's would eliminate, and the x's would eliminate. Same idea for all three of them. Okay, so when we're talking about a system of equations, it works the same way. We're going to want to look at first what method would work better. So with this example here, neither equation is in slope-intercept form, so it's not going to be easy to use substitution. So this would be an example where we're going to want to use elimination. Okay, so we look at our x values, okay, and x and negative x are actually going to eliminate each other. They're going to cancel each other out if we add them together. Okay, so then what we want to do is draw a line underneath our two equations, put a plus sign, and we're going to add the first equation to the second one. Okay, so when that happens, we have x plus negative x, and those are going to cancel out. Okay, so we don't even need to write that. Those will cancel out. They're going to eliminate. Okay, then we have 4y plus y gives me 5y. And then we have 9 plus 6 gives me 15. Okay, divide by 5. And y is equal to 3. So there's your first value. Okay, so this elimination process works really nice if you're going to have a variable that will cancel out just by adding the two equations. Okay, now just like the last 2 days, we need to find a x value as well. So now it's actually part substitution. We're going to take this 3 and plug it back in for y up into one of these equations. So just like we did yesterday with substitution. We're going to take x plus 4 times 3 equals 9. X plus 12 equals 9. Subtract the 12. X is going to equal negative 3. So then your ordered pair would be negative 3, comma 3. And there's your answer. So this second part right here is all what we did with substitution as well. Okay, this part is the new part with elimination. All right, let's look at another example here. We have 3y minus 5x equals 12 and 2y plus 5x equals negative 2. So there's our two equations. Neither one is in slope-intercept form, so we want to think about using elimination because it's not going to be easy to substitute one equation in for the other one. Okay, well, 3y and 2y are not going to cancel each other out if we add the two equations, but negative 5x and positive 5x will cancel each other out if I add my two equations together. So you're looking for either the y's or the x's to cancel each other out. Okay, so I draw my line underneath, put a plus sign because I need to add negative 5x plus 5x to get them to cancel out. And then we just start adding. So we have 3y plus 2y gives me 5y. Negative 5x plus 5x cancels out, so we're just going to cross those off. We don't need them anymore. And then equals 12 plus negative 2. 12 plus negative 2 equals 10. Now we have a one-step equation, divide by 5, so y is equal to 2. Okay, now it's a substitution, so we're going to take 2 and substitute it back in for y, sorry. I'm going to substitute it in for y, and so now we have the equation 3 times 2 minus 5x equals 12. 6 minus 5x equals 12. And then we're going to subtract the 6. So we get negative 5x equals 6. And then we're going to divide by negative 5. And we just leave x is 6 over negative 5. So your answer then would be 6 over negative 5, comma 2. Okay, now, I know I mentioned this once before when we talked about substitution, but this would be a good example why we have other methods other than just graphing, because to find the point 6 over negative 5, comma 2 on your graph would not work out very well. All right, and here is your last one here. So we look at our two equations, okay? Negative 2y and 2y are actually going to cancel each other out when we add the equations. So we draw a line, plus sign, parentheses around the second one. Negative 2y plus 2y is going to cancel out, so we don't need to write those. Then we have 4x plus negative x gives me 3x. Negative 6 plus negative 9 gives you negative 15. Divide by 3, you get x to be negative 5. There's your first answer. We're going to take that 5, that negative 5, plug it back in for x up here. So we have negative 2y plus 4 times negative 5 equals negative 6. Negative 2y plus negative 20 equals negative 6. Add 20. You get negative 2y equals 14. Divide by negative 2. You get y equals negative 7. Okay, so once again, this part right here was all what you did with substitution. We just substituted the 5 in for x, and then we solved it from there by multiplying, adding the 20, and then dividing by negative 2. So then your final answer would be negative 5, comma, negative 7. And there's your ordered pair. All right, and that is how you solve systems by elimination. We will see you later.